Hi everyone, in this video we will see the slip-over recovery scheme of an induction motor. A slip-over recovery is a technique used to regulate the velocity of induction motor. This technique is sometimes referred to as a static shear-based drive. If you take a rotor resistance control at a low speed or a moderate speed, the power is wasted as a I square R losses. So which means it is not used efficiently, so that we can say that the efficiency of this particular drive is decreases. So for this case, a slip power which is generated in the rotor circuit may be fed back, returned to the AC source for the external use, so that the drive system total efficiency can be enhanced. The slip power recovery method offers a speed control of a slip ring induction motor below its synchronous speed. So if you look at the circuit, we have a slip ring induction motor, and this is a bridge rectifier, and right side we have an inverter, and the inverter output is fed back to the three-phase AC supply. So in this circuit, if you see the slip ring induction motor, a portion of rotor AC power, that is a slip power, is converted into a DC by using a diode bridge rectifier. And then we have a smoothing reactor. This smoothing reactor is generally used to provide or smoothen the rectified current. So the output of this rectifier current is fed back to the DC terminal of the inverters. Then this inverter inverts the DC power to the AC power, and it is fed back to the AC source. So this inverter is controlled rectifier operated in the inversion mode. So this particular method is used when lot of power needs to be changed, and the speed need to be changed over a wide range. There are two methods of slip power recovery scheme. One is a static Karma drive, another one is a static shear BS drive. This is a circuit for static Karma drive. This circuit consists of a slip ring induction motor, bridge rectifier, and separately excited DC motor. So this method is generally used for controlling the speed of induction motor by injecting the opposite phase voltage to the rotor circuit. So the injected voltage of course increases the resistance of the rotor, and it controls the speed of the motor. So by changing this injected voltage, the resistance and the speed of induction motor can be controlled. So generally the static Karma drive converts the slip power of this induction motor, and it is fed back the AC power back to the line, right? So what is basically slip power? The slip power is the air gap between the stator and the rotor of an induction motor. So in this method, this rotor power or the slip power is not converted into mechanical power, so that the power is getting wasted, right? So this method, the static Karma drive, which fed backs the wasted power back to the main source, and this method is only applicable whenever the speed of the induction motor is less than the synchronous speed or half of the synchronous speed. So whenever the large speed range is required, whenever we want to control the large range of speed, the diode bridge is generally replaced as a thyristor bridge, so that the relationship between the voltage across the thyristor bridge VD1 and the speed of the motor can be changed by controlling the firing angle of the thyristor. So this type of method we can vary the speed up to the standstill. This is a circuit of static shear-based drive. The circuit consists of a wound rotor induction motor, that is a three-phase stator and a wound rotor. The rotor windings are brought out to the slip ring for an external connection like this. Then we have a rectifier. This rectifier converts the AC from the rotor circuit to DC. So this inverter which converts a DC back to the AC at a controlled frequency and phase. Then we have a DC link. It is an intermediate DC circuit that links the rectifier and the inverter. And also we have a control system which is not shown in the circuit, but this static shear-based drive has a control system which manages the operation of rectifier and inverter to achieve the desired speed and the performance. If you see the basic working principle of static shear-based drive, which is used to control the rotor current, and hence the motor speed can be varied. This is a rotor circuit control. The rotor windings are connected to the rectifier through a slip ring. So this rectifier converts the rotor AC to DC. Then the DC link, the DC from the rectifier is fed into the DC link, which act as an intermediate stage. Then we have an inverter. The DC link feeds an inverter which converts the DC back to the AC, and it feeds back to the supply or to any other load. So through a transformer, the output power, the AC power is fed back to the line. So this inverter can feed the recovered energy from the rotor back to the power supply grid, which will improve the overall efficiency of this particular system. So when the inverter feeds the energy back to the supply, the motor operates below synchronous speed. But by controlling the inverter to inject the power into the rotor circuit, the motor can be operate above synchronous speed. So overall, the static shed-based drive is a very efficient and effective method for controlling the speed of wound rotor induction motor. So by recovering the slip power and feeding the power back to the grid, which will enhance the efficiency, which will enhance the energy efficiency while providing a smooth and precise speed control. So this type of circuit is makes more ideal for applications which requires a variable speed and high torque performance. The advantages are has the ability to recover the slip power and fed back to the grid, which will enhance the overall efficiency. And using this type of drive, I can able to provide a wide range of smooth and precise speed control, and also it reduces the mechanical wear and tear problem. Then it has a high torque. It is capable of providing a high torque even at a low speed. And also it can be used in various applications, the centrifugal pumps and fans for varying the speed control to match the process requirement, crane and hose drives where the precise speed is required. Precise speed and torque controls are required. In a conveyor system, you need to control the speed of conveyor in an industrial process, and the wind turbine for efficient energy conversion and precise speed control. Thank you.